So I'll be solving some of the book problems I assigned for homework, actually for practice. So this is one of the problems that has been assigned and I'm trying to solve this. I would suggest you to first try to solve this yourself before watching the video. So in this problem they say that there are 3 dibromobenzenes, ortho, meta and para dibromobenzene, and it's cut out a little here. Suppose we have sample that we don't know which one is what, okay, and the samples are labeled A, B and C, and it's one of these 3 things. So it basically tells you that there is the ortho dibromobenzene. So we know how to draw the structures of these compounds. Ortho is going to be this, ortho dibromobenzene. Meta is going to be this, and this is para dibromobenzene. So and we have these, but we don't know which one is what. We just labeled, they're just labeled as A, B and C. A can be any of these 3, B can be this, and C can be any of these 3, right? Our nitration compound A, which has a melting point of 87 degrees centigrade, gives only one nitro dibromobenzene. So you take A, which could be any of these. If you treat this with a nitrating mixture, let's say H2SO4, HNO3, it gives only one product. So there is no major or minor, there is just only one product, and that is a mononitration product. So basically you are nitrating this ring and then you are replacing one of the hydrogens. When you nitrate a bromobenzene, the bromine is not going to leave. You are only going to replace the hydrogen in the molecule, and when you do that you get a mononitration product, and that is, there is only one possible structure when you do a mononitration. That's what you need to know from here. So mononitration product, and so gives only one mononitration product. What is the structure of A? So A gives you only one product. So you have to, of course, let me label this. This is meta dibromobenzene and this is para dibromobenzene. So if you look at the structure here, there are 2 distinct structures. So this and this are the same. So for example, if you nitrate this ring once, if you nitrate that on that position, you will get nitro dibromobenzene. So you will be getting an NO2 over there, right? And if you nitrate on this side, that is going to give you a product structure which is going to be like that. And when it comes to benzene ring, do not worry about the double bonds because the double bonds are constantly moving. So essentially you can write a structure here which is a ring, which is this. So that is what you should see. Don't worry about the location of the double bond, just look at it this way. So you have a nitro group that is to the left of this bromine here, and this nitro that you see here is to the right of the bromine on the other side, Br and NO2, and these 2 are the same structure. If you just take this molecule, if you take this axis and you rotate it 180 degrees, you get that structure. Therefore this carbon and that carbon, they are exactly the same, they're just equivalent carbons, and therefore that's one location, that's just one location, and these 2 are the same because of symmetry, right? There's symmetry in this molecule, therefore these 2 locations are the same. The second location is going to be that, which means these 2 are the same product, that's one product, and you can also get another product for the nitration, which is this, and that is same as this. Therefore this is the second product. These 2 are the second product. So when you nitrate ortho dibromobenzene, you get 2 products. That means this cannot be A. So this is not A. Alright. If you look at meta, there is one location here. If you put a nitro group there, you get one product. If you put a nitro here, which is same as this, that is 1. These two are the same location, therefore 2 possible products can result. In fact, if you nitrate just over there, you can get 3 possible products. Alright, so when you do a mononitration of the meta dibromobenzene, you will get 3 possible mononitro products. If you nitrate the ortho dibromobenzene, you have 2 possible products. So these two are the same carbons, right? Therefore you get 2 possible mononitro dibromobenzene upon nitration of the dibromobenzene, ortho dibromobenzene. Whereas when it comes to para, you have one here which is same as that over there. So these two carbons are equivalent. Remember, there is like no symmetry again in this molecule, which means this carbon is the same as this carbon. If you put a nitro here and get a product out of that, that is going to be the same as having a nitro here and getting a product out of that. In fact, this carbon is also same as this carbon because there is a symmetry here as well. Therefore, it ends up being so that all 4 of these carbons are exactly the same, and if you nitrate on any one position, you will be getting only one product no matter where you put the nitro group. Alright, so therefore, since there is only one possible product from this reaction, the structure of A is going to be the para dibromobenzene. So that is A, and so we just solved what A is, which is the para dibromobenzene, and then they ask you what are the structures of B and C. Alright, so for that they have given you the information as well. On nitration, B gives 2 dinitrobromobenzene. So B gives 2 dinitrobromobenzene, which means we see that this structure that you see here, right, gives you 2 possible products, not 3, not 1, but 2. Therefore B has to be the ortho. A is para dibromobenzene, B is ortho dibromobenzene, and obviously C is the one that gives you 3 dinitrobenzene. So C gives you 3 nitro dibromobenzene, right? So location 1, location 2, and location 3, and therefore C has to be the meta dibromobenzene. So I'm sure this could be a little confusing since this is the first time we are discussing this kind of problem, but I would just suggest you to read this problem first, try to think about it, and then look into the solution that I have solved here. Alright, so that's the structure of A, and that's the structure of the product you get from A. I will draw the structure of B and the products you get from B. So this is B, which is ortho, so B gives 2, so B has to be ortho. Alright, so the 2 products you get from bromination of the meta, the ortho, is, these are the 2 possible products for B, and C is, you get 3 possible products, so 2, that is 3. Alright, so that's the meta giving you the 3 products. So just 1, just 2, and all 3.